Alright, so in this video, we're going to be talking about how to simplify the expression fourth root of 128. This is contrasted with the last example, which we were handling a square root. So in this video, I'm going to kind of illustrate how we handle roots aside from 2. So how do we go about doing this? We're going to use the factor tree method, just as we did before. So first thing we want to do is put 128 at the top of our factor tree, and then see if we can find two numbers that multiply that to 128. If you see that your number is even, try dividing by 2. This makes your life a lot easier. So if you notice, if we divide this by 2, plug it into a calculator, if you like, you get 2 and 64. All right, now 64 is also even, so it's divisible by 2. In which case, I'm going to divide this by 2 again. This gives me 32 times 2. And then 32 is also even, so I can continue breaking this down just with powers of 2. So this gives me 2 times 16, and then 16 is 2 times 8, and 8 is 2 times 4, and 4 is 2 times 2. So sometimes these factor trees can get obnoxiously large. But alas, you end up with a complete factorization. These things all are getting multiplied, and these all, when multiplied, give us 128. Okay? So now the thing we need to notice here is that we're looking at a fourth root. Like in the last example, we had a square root, so we clustered all of our factors into groups of 2 so that we get some cancellation. In this case, we want to group it into clusters of 4 because that's how we're going to cancel a fourth root. The only way you can cancel a fourth root is with a fourth power. Okay? So rewriting this, here's a cluster of 4, here's a cluster of 3. So we're not going to be able to break down this guy, but we can break down this. This will end up canceling the fourth root, at least in part. So if we were to rewrite this, I have fourth root of 128, and that is equal to fourth root of 2 times 2 times 2, so that's 2 to the third, times 2 to the fourth. Now we're going to use our power rule so that we can distribute this radical over products, or it's rather the product rule. But it's a power nonetheless, so I kind of think of it as the power rule. That's just me. Okay, so we have fourth root of 2 cubed. That's what we end up with now. So we're breaking this up over the product. And we have fourth root of 2 to the fourth. Okay? So this can't be broken down any further, this 2 to the third, because we have a fourth root here, and we only have powers 2 to the third in this case. So we're stuck with what we have here. However, in this case, I have 2 to the fourth and the fourth root. So in this case, these will cancel. Okay? Rewriting the thing that doesn't cancel, I have fourth root of 2 to the third times just 2, because the fourth root cancels the power of 4. Okay? The powers have to be the same here in order to cancel them. Okay? So in this case, I can rewrite this. I don't like having this thing over here because then sometimes that confuses people thinking it's inside the radical. It's not, so I can just bring it out in front. So I have 2 times fourth root of 2 cubed. And if you like, you can simplify this 2 cubed and turn that into an 8. So you have 2 times fourth root of 8. And this does not simplify any further because, as I mentioned before, this 2 cubed does not break down any further, and it cannot cancel this fourth power. So we are stuck with what we have here, and this is done.